Welcome to RGES Algebra 1. This is lesson 32B. I would like to begin with the scripture, and I'm going to read the first 4 verses of Psalm 96. It says, "O sing to the Lord a new song, sing to the Lord all the earth. Sing to the Lord, bless his name, tell of his salvation from day to day. Declare his glory among the nations, his marvelous works among all the peoples. For great is the Lord, and greatly to be praised. He is to be feared above all gods." Now, not only are this is about praise, it's about worship, it's about singing to the Lord and blessing his name, declaring his goodness, his power, his character, blessing his name. Okay. Extolling him, lifting him on high. But it is also about, the focus, I would say, is about telling of his works, proclaiming his works. In fact, it says, declare his glory, his among the nations, his marvelous works among all the peoples, tell of his salvation. So we are to declare or proclaim 3 things, okay? His salvation. So one of the things this means to me is that when God is doing something in our lives, we are to talk about it. When we know his salvation, when we have experienced his grace, his mercy, his forgiveness, his kindness, we're to proclaim it to others. When we have seen his power, his loving kindness, his provision, his strength, we are to share it and talk about it. So don't keep it to yourself. Talk about the goodness of the Lord. Talk about every place you have seen him at work and alive in your life. And if you don't feel that you have much to testify of, much to proclaim, then turn this into a prayer. Lord, I want a testimony. What is a testimony? A proclamation, learning to tell my story of how God has interacted with my life. So if you don't feel you have much to share, ask him for more. Lord, let me see more of your goodness so that I can speak of more of your goodness. Let me experience more of your forgiveness, being confident of how you have taken away my sins and continue to guide me and lead me into a righteous life that pleases you. Let me experience that so that I can speak of it. Okay, so there's 2 ways we can take this. Learning to share it more, don't be shy. People want to hear that God is real and at work in the lives of people. And so you don't be shy to proclaim it. And if you aren't confident in what you have, your part of the story, then ask him to reveal himself more to you. In Jesus' name. Let's go ahead and review sections 12.5 and 12.6. 12.5 is about simplifying radical expressions, and I'm just going to do a few problems here by way of reminder. Now, the first section says that for all these problems, we're to assume that all variables stand for positive numbers, so I don't have to worry about absolute values here. So what do? We think the first even number lower than that would be a to the 6, so we can take out, if you divide a to the 6 by 2, you've got 3 groups of a on the outside of the radical, and because this is odd and not even, you've got a remainder of 1. So that's going to be my answer. Number 9. So I can look at each variable separately. I'll look at my x's, and again, I'll be able to pull 1 out and have 1 under the radical. And now recall that we cannot leave a radical in the denominator for simplest form, so I'll pull it up to the numerator. And Square root of y times square root of y is simply y in the denominator. Hopefully these are becoming quite easy for you. Now, when we are doing this level of problem, there's always more than one order in which you will be solving these, so you might do this a little different than I do, but I'm going to simplify this by taking it out, simplify this by taking it out, and combining these as though I were looking for add a radical with the fraction under it. Okay, so I'm going to write these in such a way the cancellation will be obvious to you. I'm thinking about it this way. I'll try to draw this in. Again, there is more than one way to look at it. And you could do it all in your head, perhaps, but, paper's cheap. Go ahead and write down steps. These will cancel, 3's will cancel, 5's will cancel, 1x will cancel, and I'll end up with the square root of x to the 6, which equals x cubed. Now, my assumption, it says, for number 17 through 23, is going to be that the radicand is a positive. That means everything under here is positive. Well, anything squared is positive, so this means that, just like if I said x, let's see, what do I want to say? Well, if I say x squared equals 36, it could either be a positive 6 squared is 36, or a negative 6. So just because everything under there is a radical, I want to kind of think in terms of this example. So when I think of the square root of that, I must have the absolute value. This would be the absolute value of 6, right? And so up here, I need to have that absolute value of sign. Other than that, pretty straightforward. Now that's all I'm going to cover in lesson 12.5. I'm going to assume that the explanation that was given last time and your ability to work through these problems, that you understand it. If not, what's the rule of thumb? Always text me. Now let's go on to 12.6. This has to do with solving equations that have radical signs in them. And so I will go ahead and do 4 of these problems. Number 1, now what we want to do is we want to isolate the radical. That means I want the radical on the left-hand side and everything else on the right-hand side. Well, right now that's what I already have. So then you want to square it. And if we square the left side, we square the right side. And this becomes x plus 3 equals 49. We're going to, that was a weird thing. We're going to solve by taking my 3 to the right side by subtracting, and I'll get x equals 46. Go ahead and check it. 46 plus 3 is 49. The square root of 49 is 7. Let's go ahead and do number 5. Now I need to isolate the radical, so I have to take this to the other side. And look what happens. 9 minus 13 is negative 4. So when you square both sides, okay. Actually, by the way, I could stop here. I could stop right here and say no solution. Why? Because is the square root of anything a negative number? No. Because what times itself is going to end up with a negative. I'm sorry, that's the square. Yeah, I could not have, if I take the square root of something, I can't have a negative, because nothing times itself underneath the radical, okay, will be negative. So there is no solution for this problem. You could just stop right there. Or if you did not, you could square both sides. You get x equals 16, but then when I plug it back in and check it, I'd get 4 plus 13. Does that equal 9? No. So either way, you could either recognize it when I end up with just the radical on the left and a negative on the right, I have no solution. Let's look at number 7. My radical is isolated, so I'll square both sides. This becomes 3x plus 4. 5 squared is 25. Subtract 3x. 25 minus 4 is 21. Divide. And x equals 7. Plug it back in. You get 21 plus 4 is 25. The square root of 25 is 5. And let's do number 9. The square root is already isolated. Square both sides. We're going to get 7x minus 10. 4 squared is 16. Add. 7x equals 26. Divide. 26/7. I would be happy for that answer, but to be able to compare apples and apples, take out your calculator, and that will be 3.71, which is the answer in the book. So now we want to talk about two new ideas, the Pythagorean theorem and inequalities. Now the Pythagorean theorem is a very, very useful theorem in mathematics, and you'll have lots of reasons to use it as time goes on. But basically, it says that if you have a right triangle, this is a right triangle right there, that means right means a 90-degree angle. If you have a triangle with a 90-degree angle, the side opposite that is the longest side. The longest side is called the hypotenuse. These other two sides are called they're just called the legs of the triangle. Now this theorem states the longest side, which is always referred to as c here, c squared equals a squared plus b squared. Now he does draw some visual geometric examples of this and explain why, but I actually prefer to leave all that for something the student proves when we're doing geometry. And so I'm going to skip over that, but you're free to look at it. Okay, so simply what we do here is if you have a right triangle and you know two of the sides, the value of two of the sides, then you can figure out the hypotenuse. Why? Because a squared plus b squared, the two sides, equals c squared. Okay. So that would be my first step. Go ahead and square. 13 squared is 169. 21 squared is 441. Add them together. You're going to get 610, and so c is the square root. If c squared is 610, c is the square root of 610. And he usually picks up, I might simplify at that point, he usually picks up the calculator and crunches it out. Approximately 24.70. And that's all there is to it. The big key is to recognize we're always talking about a right triangle, not just any triangle. It has to be a right triangle. And then just remember c squared, the hypotenuse, equals a squared plus b squared. And many students have already been exposed to this before they get to Algebra 1, so I don't think it's too hard of an idea. Now, what if instead, rather than being given both the legs, instead I was giving the hypotenuse, 24.7, it's a right triangle, and I'm given this, one of the legs. What is the other leg? Well, I simply would fill this in a little bit differently. I've got the hypotenuse equals a squared plus b squared. Okay. And so I've got 24.7 squared equals, it doesn't matter which I pick for A or which I pick for B, 21 squared plus b squared. Hopefully you can see that this would be, based on the earlier problem, 610 equals 441 plus b squared, subtracting, and I'm going to get b squared equals 169, or b equals 13. You just work the problem in another direction, right? You're plugging in, if you've got one of the sides to solve for, you've got to make sure that the hypotenuse is on the other side of the equation. So you've done so many problems at this point like that, as far as manipulating your equations, that I don't think that that would be too tricky for you. So all we're going to do is pick up just a few of these, and feel free to use your calculator. Now, when you get to word problems, let's look at number 21 together to just show you how we use this. And it says Calvin's to Phoebe's problem. Calvin Butterball lives on Elm Street, 253 meters from its intersection with Oak. Phoebe lives on Oak Avenue, 113 meters from its intersection with Elm. How many meters could Calvin save by walking directly? So we would always, in a problem like this, go ahead and sketch it. We've got Oak and Elm. And hopefully you would see that this would be 257 meters. Just pulling this right off the description. This, on Oak Street, it's 113 meters. This would be where Phoebe lives. This would be where Calvin lives. And what if he went up that straight rather than going down to the intersection and up, or over to the intersection, to the right, to the intersection, and then up? Well, we're asking, what is the hypotenuse? And as long as you recognize that, the intersection is at a perpendicular angle, so that's 90 degrees. And so this just simply becomes a very easy Pythagorean theorem. We want the hypotenuse. We know that it's 257 in one direction and 113 in the other direction. And take the square root, right, to figure out C. So that just shows you, it gives a quick illustration for how we use the Pythagorean theorem. Now, the next idea we're going to do is we're actually going to skip forward now into chapter 13 and talk some about inequalities. I think that we have nailed down the basics for chapter 12. We are nearing the end of the book, so I want to pick up, rather than hammering down with more complex problems, the rest of chapter 12, we've got all the basic ideas. We're skipping a couple basic ideas, but they're typically going to be covered in Algebra 2, so you'll be fine. So let's go to 13.1. 13.1 is going to talk about graphing inequalities. Now we're talking about graphing on a number line. Think about a number line with me a minute. If you have a number line and you have 0, everything to the right is going to be positive. Everything to the right of the 0, everything to the left of the 0 is going to be negative, and every point to the right is going to be greater than every point to the left. What do I mean by that? Well, if I have 3 and 7, then 7's to the right of 3, so 7 is greater than 3. This is greater than. If I have a -4 and a -2, then -2 is going to be greater than -4. The third thing I could say is that keeping these examples going, 3 is greater than negative 4. Even though this is a bigger value, 4 is a larger number than 3 because of the signs. So I think that that would be something you've already know. Now, how would I graph that if I want to say x is greater than negative 2? Well, I'm going to put a number line on. I usually like to put the 0 and then the other point we're talking about. And I want to graph x is greater than negative 2. Well, find my point, negative 2. Because I'm not including it, I will just put an open circle there. If I wanted to say greater than or equal to, I would close that circle. And because x is greater than it, x is going to be to the right. So everything to the right will graph it like that. What if I wanted to say x is less than or equal to 3? How would I do that? To graph that, I would simply draw a number line, put a 0, put a 3. It's less than or equal to, so I'm going to graph the point 3, and I'm going to fill it in because it also wants to include it. It's either less than or equal to. If it's going to be less than, so that's equal to right there. If it's going to be less than, then I want to graph everything to the left, just like that. So this is a less than sign. And this is a greater than sign. When I put the line under it, it means also include the number, less than, equal to, or greater than and equal to. So all you have to do is either, if I give you the expression, you need to turn it into a graph, or if I give you a graph, you need to turn it into an expression. X is greater than, don't include it because it's open, rather than shaded, which we would call closed, it's greater than 28. If I had negative 2 there, and there's a 0, and I want to have a graph that looks like this, I say X, I read off the number, negative 2, do I include it? Yes. Am I shaded to the left or the right? Shaded to the left, so it's less than, and because it's also shaded in, it's less than or equal to. So if I give you that, you can convert to that, and if I give you that, you can convert to that. And that's it. I don't think you'll have any trouble doing these. Let me give you your homework then. So you're going to have your homework and I'm going to send it by email, a quiz 19 covering 12.4 through 12.6. Now next Tuesday, which is going to be 5/5, May 5th, in the morning at Hoffmantown, we are going to have a day for drop-off and pickup of papers. You don't want to miss that. Your parents will probably have received one email already, will receive another with the exact times, and it will be like the last time. It will be a drive-by where you don't even have to get out of the car, and we'll be exchanging papers. It's important that you do that because you see next week is lesson 33, and that is our last week before we, actually, I think that, yeah, that's right. It's hard to believe it's that soon. It's our last week before we have our review. So it's next week, then week 34 is review, and then you'll have your final exam. So you want to really make sure that you get these papers back and forth so that you have the best feedback you can on what you need to review and study to do well. God bless.